Hey everyone, this is Manish and welcome back to my YouTube channel. So in this video, I'll be discussing binary search. Okay, so there will be no code, there will be no methods, there will be no rules that I'll ask you to follow. I'll just make sure that you understand binary search by your intuition. Okay, I'll explain intuitively that how a normal search works, how binary search works. There will be no code, there will be no rules. Okay, you don't need to follow any kind of rules, just follow your intuition and you will find how binary search works efficiently. Okay, this is very simple. People often get confused like how that recursive binary search works, how iterative binary search works, and they sometimes mess up during the coding interviews. Just simply follow your intuition, you will easily understand how binary search works. Okay, so before proceeding, I want to make sure that you please do subscribe to my channel for more contents related to your placement and your interview preparation. Okay, because that gives a lot of encouragement to me to make more contents just for you guys. Okay, so now let's proceed. So what is our problem statement? Our problem statement is that we are given a sorted array. Okay, so for binary search to work, we need to have our given array to be sorted, right? It can be either ascending, it can be either descending. Okay, there's no rule that binary search only works for ascending sorted order or the descending sorted order. There is no rule. Any kind of sorted array is perfect for binary search. Okay, so in our case the array is sorted from left to right in ascending order. Okay, so we have total 11 elements, right, starting from 0 to 10. Okay, all are sorted. We have to find an element inside an array efficiently. Okay, so let's say I want to find this element 25. Okay, so 25 is the element I want to find. The simplest thing to find this element is just scanning the array from left to right, and whenever I find the element 25, we'll return the index. So I just scan the array from left to right, I get the element 25 at index 6 and I'll return 6 as my result, that I have found my index at the position 6. So what will be the time complexity? I scans every element. In the worst case, the element can lie at the end of at the right hand side. Okay, so the time complexity would be order of n, which means the linear time. So this is how normal search works. Now how can we decrease the time complexity and increase the efficiency? Okay, that's the advantage of an array being sorted. Okay, if it would not have been sorted, then binary search would not work. Okay, this is just a simple game of your intuition. Okay, just look at this. So we'll first find the middle element of the array. Why, I'll tell you later, but just find the middle element. Okay, so now how can I find the middle element? Simple formula is, if this is your, let's say, left pointer and this is your right pointer, which means this is pointing to the leftmost element, this is pointing to the rightmost element. Okay, now how can I find the middle element? Simply L plus R by 2, but I will suggest don't do this. Why? Because this L plus R will sometimes give overflow if the array is huge. Okay, let's say the array contains 10 power 9 or more than in that element. So L plus R will definitely give you an integer overflow. That's why I'll ask you not to use this formula. Okay, so what would be a better formula? L plus R minus L by 2. This is a better formula. Why? Because R minus L will not give you an integer overflow, because it will automatically decrease the value. If R is very large, R minus L will always be lesser or equal to the R value. Okay, so it will not overflow. So that indicates how much shift you need to do to find the middle element from the left point. Okay, so now just find the middle element of this array using this formula, right? Okay, so what is the value of L here? 0 plus, what is the value of R? 10 minus 0 by 2, that means 5, right? So in this case, this is our middle element, 23, right? Now don't need to follow any formula, don't need to follow any code. Okay, don't just see any code, just follow your intuition. Array is sorted, which means the middle element is placed at the 5th index. All the values on the left hand side of the middle element is what? Is smaller than this element, right? And all the value on the right hand side of the middle element is what? Bigger than the middle element. This is fine, this is simple, you don't need to follow any rules or any code, this is your simple intuition, okay? Now we have to find 25. 25 is what? Bigger or lesser than the middle element? Bigger than middle element. So our intuition says that 25 should lie on the right hand side of this middle element because it is bigger than the middle element, okay? So now we can make sure then we don't need this part. We don't need the part that is left hand side of the middle element. If in case that our search item would be less than this middle element, what we should do, we are making sure that the right hand side part will not be needed because that will the search value will definitely lie on the left hand side. That is the beauty of binary search, because that is how your intuition says that you are in every step you are making sure that you are excluding one half of the part. So your search will occur on the other half, right? So in our case our search will proceed in this half only. Okay, so before searching we'll always check whether the middle element is our search element or not, right? If our middle element is our search element, then we don't need to search anything, we don't need to traverse any half, right? We are simply returning that index. But in our case, the middle element is not equal to our search element. So what should we do? We'll proceed our searching on the right hand side, okay? Okay, so our search domain will start from this point and up to this point. Why? Because all the values on the left hand side of the middle element are lesser than it, and we want something bigger than the middle element. So we should proceed searching this side. Now in the same way, we should find the middle element of this part. What should be the middle element? So in our case, L will be this and R will be this. What will be the middle point? 6 plus 10 minus 6 by 2, that will be 8. Okay, so this will be our mid, right? Now just compare this search value with the middle element. What is the middle element? 32, and the search value is 25. So 25 is less than 32. What does this mean? The 25, which means our search value would definitely lie on the left hand side of this middle element, and this is not equal to the middle element. So we are very much sure that the search element will definitely lie on the left hand side, okay? So we have again reduced our domain from this point to this point, okay? So in that case our R value will be this and L value will be this, right? So what will be the middle? In this case we only have left these two value, okay? So what will be the mid in this case? 6 plus 7 minus 6 divided by 2, that will be 6 only, because this gives 1 by 2, which means 0 in integer division, okay? So 6 only. So what is 6? This will be our mid. Now compare this with our search element, and yes, we have got our element. So the middle element equals to the search element, right? So we have found our element. So this is how the whole binary search works. You don't need to follow any rules, you don't need to follow any method, just your intuition works here, okay? So now the binary search is done. So what will be the time complexity? You already know it, I already know it, and everyone knows it, right? There will be log of n, where n is the number of element. But how? How that log n comes in the picture? You know, finding log n in these steps is pretty much difficult. How do you say that log n will be the time complexity of binary search? So let's see how log n comes. So first of all, look at this. In each step, we are excluding the half of the portion, right? In the first part, we have excluded the left hand side portion. In the second half, in the second iteration, we have excluded the right hand side part. So I need to find how many iterations should I execute to get only one element, okay? So in our case, the recursive formula will look like, if n will be the number of elements in an array, so the recursive formula will be Tn equal to T of n by 2 plus some constant value. Why n by 2? Because we are searching only the n by 2 elements in each iteration, right? So okay, what will be the solution of this? You don't need to follow any method also. You just work on your intuition, okay? So what is T of n by 2? What will be T of n by 2? Simply follow this. Tn equal to T of n by 2 plus c. So T of n by 2 will be T of n by 2 square plus c, isn't it? Because it will further gets divided into half. So n by 2 by 2, that will means n by 2 square. So simply write T of n by 2 square plus c, and the c was previously there, plus c. So what will be T of n by 2 square? This will be equal to T of n by 2 cube plus c plus c plus c, okay? Because this will get again further divided by 2. This is how it will remain T of n by 2 power k plus k into c, because c will be having k times, right? So now when it will stop, the base condition will be T of 1. When we have only one element left, that we have already seen in our case. So we have one element left. So how can we make this as 1? When n by 2 power k will be equal to 1, right? Which means 2 power k will be equal to n, isn't it? What will be the value of k? K will be log of n base 2. This is how we have found out that the number of steps needed to make this binary search stops will be log of n base 2 if we divide our array into two parts. So in the initially I said, why should we find the mid value, is that we make our number of steps count will be log of n base 2. If we make our array divided by 3, we make 3 equal components, it will be log of n base 3, okay? So in any case, if we divide our entire array in k equal parts, the complexity will be in same way log of n base k, right? So this is how the binary search works. So this will be called k-way search, right? So in our case, as k equal to 2, we'll often call it as binary search, okay? So hope this video will clear your concept and your intuition about how binary search works. This is just a simple video. I've made it a longer for you to understand in a better way. So hope you enjoyed this video. If you like this video, please give a like and let me know in the comment section if you have any questions or suggestions regarding this video, okay? And also please do subscribe to my channel for more contents related to interview preparation and your placement, okay? So see you in the next video. Till then, take care, stay happy, stay motivated, and goodbye.